The last new theorem is the complex conjugate theorem. This theorem says that if the roots and zeros are not real, then they are complex. Complex are imaginary numbers. Complex roots will always exist in complex conjugate pairs. So if one root is a plus bi, then its conjugate pair a minus bi is also a zero of the function. So what that means is if one root is 4 minus I, then another root is 4 plus I. We could use our rule and determine the number of real and imaginary roots. Now again, we already know that this function is cubic, and it has 2 imaginary, so that tells me that there is only going to be 1 real, and I can determine if that 1 real is positive or negative based on sign changes. So I have 1 sign change, no change, a change, so that's 2. So that means that there are either 2 or 0 positive real roots. Since I already know that 2 of my 3 roots are complex, at this point I know that there are no real roots then that are positive. There are no real . If I plug in a negative x, then I get a sign change from x squared to x, meaning that I have 1 real negative root. Using our P divides Q, I need factors of 51 over factors of 1. So 51 divides by 1. 51 divides by 3. And 17 and 51. So that tells me if I am using synthetic, I would want to try negative 1, negative 3, negative 17, or negative 51. Usually our answers are smaller and they're easier to work with, so you would pick negative 1 or negative 3. So that tells me that negative 3 is a 0, and that x plus 3 is a factor. And then that leaves x squared minus 8x plus 17. This gave the 2 imaginary. And this gave the one negative real. So it said to find all of the roots. So root 1, root 2, negative 3 is root 3. That summarizes the complex conjugate theorem for roots. So again, just to summarize and put everything into play, let's just use stopping. You have your rational root theorem. Which is your P divides Q. You have Descartes' rule. And you have your complex conjugate theorem. You're going to use all of those to solve your problems. Please complete the 6-7 and 6-8 assignment for Monday.